Hello all, welcome to today's session on new preservation technologies. In this session, we will be giving a brief introduction to new preservation technologies and talk about why is it gaining the attention of food industries. Then focus on the first preservation technology, which is the high hydrostatic pressure method. So let's get started. In the last few videos, we spoke about several preservation techniques, including manipulation of extrinsic, intrinsic, and implicit factors. We also spoke about irradiation and chemical preservation of foods. In this video, we will talk about new preservation technologies that are gaining the attention of food industry. Now, why do we need new preservation technologies? In traditional methodologies like pasteurization and sterilization, we are subjecting food products to very high temperatures, which is around 70 to 80 degrees Celsius in case of pasteurization and greater than 100 degrees Celsius if it is sterilization, meaning the organoleptic properties of food and the nutritional content is impacted. On the other hand, when we make use of new preservation technologies, most often it being non-thermal, aids in better retention of nutritional and organoleptic properties like that of a natural product. As a result, consumers have a positive outlook about these products. They are more than happy to buy products that are treated using new preservation technologies. In fact, they cannot differentiate between products subjected to these new preservation technologies and their natural counterpart. So it's a win-win situation for both the consumers as well as the food industry. The second important benefit is in terms of improved shelf life extension, as several chemical degradation reactions are inhibited or not augmented due to lack of temperature effect. So for carrying out several chemical degradation reaction, temperature acts as a triggering factor. It enhances the rate of chemical reaction. So if you're not supplying temperature, then most of the reactions they are inhibited or at times they are very slow that it does not have an impact on the product during the storage period. Third one is the cheap and convenience. So whatever methodology we are using, if it is a new methodology, we try to do a cost to benefit analysis. Meaning, if we are investing X amount, what is the return in the long run? Although the capital investment of a new preservation technology is on the higher end and it is expensive, in the long run, it is considered to be cheaper and affordable. The process is quick as all we have to do is put all the food items in an automated machine, set parameters like time, temperature, the number of runs you want to carry out, and then we have the food product, which is your output, the treated food product. Now, what you have to remember in this process is compared to the traditional preservation technologies, you do not have to carry out any sort of pre-treatment before placing it in the automated machine. Last but not the least, it's relevant when we particularly talk about irradiated food. Irradiated food needs to be labeled. Wherever you're releasing irradiated food, you have to label it. Now, when consumers see such a labeling, they have negative connotation about the product. They tend to believe that the food could potentially be radioactive. You cannot expect the layman to know the dosage level of radiation used for treatment, right? So they have an overall negative impression about irradiated food product. When you use new preservation technologies, there's no fear of such residue being left behind. So it encourages the consumers to buy your food product. One of the first preservation technologies that we'll be discussing is use of high hydrostatic pressure. As the word suggests, we are talking about pressures of the range 450 to 600 megapascal for destruction of vegetative cells and 1000 megapascal for destruction of spores. It's based on a principle called as Le Chatelier principle. So Le Chatelier, he is a French scientist who gave out this principle during the French Revolution. It was in the early 1800s. He stated that any reaction, conformational change, or phase transition accompanied by a decrease in volume will be favored at high pressure, meaning the pressure and volume, these two variables are inversely proportional to one another. If you increase pressure, there is a decrease in volume and vice versa. In other words, you can say at high pressures, reactions contributing to increased volume is inhibited. Now, I have tried to give you a diagrammatic representation of the whole process. So, if you see this here, this is a closed system containing constant volume. So, a closed system has a constant volume. You're placing your food in the system which has a liquid that is able to absorb the extra pressure uh, that is produced during the high pressure treatment. Now, when you subject the food in the constant system to a high pressure using piston, what happens is that the volume of the food decreases by removing all the void spaces present in food. At the same time, there is also microbial cell churning, modification, and leakage, resulting in cellular death. The most important thing that we have to remember with regard to this methodology is that the food quality is not impacted. Coming to the effect of high hydrostatic pressure on microbial cell and food. First, as far as microbial cell is concerned, several reactions are hindered as proteins become denatured at pressures of 400 to 600 megapascal, which implies that enzymes also become denatured as enzymes are made out of proteins. If enzymes are denatured, it interferes with the metabolic pathway, that is the oxidation reduction reactions Krebs cycle, which is important for production of cellular ATP, adenosine triphosphate, which is the energy molecule. If there is an interference with these various metabolic pathways, ATP becomes inactivated or there is less energy available for growth, reproduction, and adaptation to the new stressful environment, causing cell death. Second important effect of pressure on microbial cell is the alteration of cellular morphology. The cell membrane and the cell wall is altered, causing leakage of nucleic acid. And if there is leakage of nucleic acid from the cytoplasm, then of course it results in cell death. Not just that, if the fluidity of the membrane is affected, then the adaptation of the microbe to the stressful environment is reduced. And also it can promote inflow of certain ions into the microbial cell. The second is impact of high hydrostatic pressure on food. As far as food is concerned, because it's a non-thermal process, there is no breaking of chemical bonds, meaning no off flavor production during storage period. The process can be carried out even at refrigeration temperatures, often leading to strengthening of hydrogen bonds in food. Now, sensitivity of microorganisms follow this order. Gram negative, they are more sensitive than fungi, which is more sensitive than gram positive, and the spores, they are the most resistant of all. Now, we have spoken about this methodology. It seems to be very fascinating at the first go. But what are the limitations associated with high hydrostatic pressure? There is high investment cost associated with high hydrostatic pressure. Just to give you an idea, the cost that we are talking about, although it might seem very less, okay, for 1 kg of product produced, you're talking about zero point 0.3 euro, zero point 0.3 euro per kg, whereas in the non-traditional, in the traditional method, it is let's say 0.005 euro per kilogram. Although this amount might seem very small, it has a very high impact in the end product as it leads to an additive effect. Then it's a batch treatment process. You can imagine you cannot produce a lot of quantity of the product in order to be able to reduce the production cost. No, production cost is high. And then used for niche markets like guacamole, fruit products, oysters, aroma concentrates. The reason why it's used for niche market is because A, the high investment costs, B, batch treatment process. Thank you for staying with me through the lecture. If you have any queries, please put them in the comment section and I'll get back to you as soon as possible. In the next video, we'll be talking about a new preservation technology called as pulsed electric field. Until then, bye.